Hello, everybody. How's the first day of ECC?
Nice.
Hot.
Pretty hot, yeah? Yeah, what was the best talk today that you heard? Okay, so how many talks have you heard today? You can just raise the amount of fingers. Okay, 5? Okay, 5 is the winner. Okay, great. So that's impressive. I actually heard one, but now I'm going to drastically increase this amount during this meetup. So hopefully you're going to have fun. I will try to be pretty sticking to the kind of details and technical stuff, because as far as I understand, mostly we have here pretty technical people. Who are actually developers or in general engineers here? Can you raise the... Okay, almost everyone. Who are, kind of more on the high level, on the business side or marketing or whatever? Okay, so some engineers are doing marketing. Great. Okay, cool. So my topic today is about MEV and how MEV it can be useful for bridges. Does everybody know what MEV is? Okay. Can someone, put it in kind of a couple of words? Sorry? Like a super short explanation. What the heck is the freaking MEV? Minor extraction value. Yep. Or minimum extraction value, or maximum extraction value. People, do. Yep. Okay, so pretty good explanation. So Ethereum miners, taking into account that they have an ability to order transactions in the block, they're capable of extracting some additional value. And actually there are some specific API developed in a very particular Ethereum node implementations that give you an ability actually to tell to people that are searching, they're called searchers, right? To tell to people who are searching the opportunities for arbitrage in general, they are able to submit to particular API points of the miners the very specific transactions that literally mean the following. If you are going to put this transaction right after this particular transaction that is there in the pool, then I'm going to pay you some amount of money. And the reason why some people are willing to submit such transactions is because the first transaction, the actual transaction that they are referring to, is introducing some kind of disbalance in the pools and in the prices. So it creates an arbitrage opportunity, and then this arbitrage opportunity can be resolved. So for example, imagine a kind of user, pretty stupid one, that is, for example, not using that is using just a single DEX, that is not using an aggregator, right, for doing a swap. And he's doing a swap of a size of 1 million on the pool of the size of 10 million. So he creates an insane arbitrage opportunity, and somebody can buy the other token on the other exchange, or maybe several of them, and actually then sell here and instantly get the value out of it. These opportunities are not only about arbitrage, they're in general some kind of opportunities, and I recommend you to take a read of the pretty famous article at the moment, which is called "Ethereum is a Dark Forest," and there is an additional kind of extension of this article. And the main motive in this article is about the fact that there are lots of people, lots of bots that are constantly monitoring what the heck is happening in the mempool. Because out of the Ethereum mempool, people are capable of extracting, or just front running of the transactions, people are capable of extracting tons of money. And all of this is because of MEV, because bots are capable of submitting the transactions and just saying that, hey, execute these transactions instead of this one, or execute it afterwards, or things like that. So this is MEV. This is what MEV is, and this is what MEV is about. Some people are saying that this is super bad because like it removes the value out of the ecosystem, so it's kind of not that cool. Others saying that this is extremely bad because users get front run, or you can create so-called sandwich attacks on the users, especially on the big transfers. Well, I can tell you that there is an alternative point of view on this. Sometimes MEV is actually capable of solving some pieces of your problems from the multi-chain world. So I'm the CEO of Aurora Labs, the company that builds Aurora protocol. Aurora is so it is not that big, right? And it's a little bit too much light here. Can we actually turn off the light a little bit? Does anyone know how to do it? Okay. Nada, can we turn off the light?
Why?
Yeah.
Okay.
So while you're doing this, just continuing about Aurora. So Aurora is an EVM solution and an L2 to Ethereum that is working on top of Near. Our main idea of building Aurora was that Near is the scalable protocol. It is already there. There is no need to replicate the good consensus, decentralized network of validators, fast, like low transaction speeds and stuff like that. There is no need to do it. Instead, the only thing that is required is the runtime. And Near native runtime is different. Near native runtime is its own Near virtual machine. So it is not EVM compatible, which means that people that already developed their solutions for Ethereum, they're not capable of launching their applications there. So that's the problem. So, so we have developed Aurora. It is a smart contract on top of Near, but from the standpoint of an ordinary user, it is viewed as a separate chain, a separate L2 that is working on top of Ethereum. Now, it obviously has a Web3 compatible interface, or RPC, which means that all of the existing tools can connect to it. Tools that you love, like Remix, like MetaMask, like other wallets, and like Etherscan, and like many, many other things, great things from the Ethereum ecosystem. And our base token is ETH, actually. So we are not forcing people to buy another token in order to operate on our chain. Moreover, just recently we launched a product that is called Aurora Plus, and this product is actually allowing for the people to get free transactions, a certain amount of free transactions. So, and one additional part of the solution that we have is the bridge, right? So here is the multi-chain story comes into play. So we are the developers of the Rainbow Bridge. Please raise your hands, the ones who have tried Aurora or Rainbow Bridge. Okay, some people did. Okay, great. So Rainbow Bridge, it is a trustless and generic bridge, and this is the main part that we are going to discuss here, right? And by saying trustless and permissionless bridge, I mean that anyone is capable of participating in this bridge, and there is no such thing as a validator of the bridge. The way how we approached it is pretty unique and extremely complicated. I do not recommend anyone who is sane doing the same thing. Just reuse our code. So the reason why I'm saying this to you is because it is super complicated. So what we did is that we implemented Near Light Client and Ethereum Light Client as smart contracts on the opposite chains. So Near Light Client as a whole operates as a smart contract on Ethereum. An Ethereum Light Client, a super complicated piece of tech, operates as a smart contract on Near. So these two smart contracts are working there. From time to time, we have an external services that are keeping these light clients in sync with the main chain. So we call these services relayers. And these relayers are just submitting blocks. So every 14 seconds, there is a transaction on Near blockchain where our own relayer is taking freshly generated Ethereum block and sends it to the Near blockchain, to the Ethereum light client of the Rainbow Bridge. And every 4 hours, we are sending the Near block to the Ethereum. And anyone is capable of being a relayer, because light client, the only thing that it does, it just verifies that the block was created according to the consensus rules of the chain. And one of the things that my team is taking care of right now is that we are ready for the merge, because this is the change of the consensus. So if you are reading, kind of short expressions of what do you need to do when the merge is going to happen, the first thing that is there is that you don't need to do anything. Well, this is not for my team, right? So I need to change everything because of this, because the consensus is changing. And a major part of our solution is Ethereum light client implemented on Near. Now, when you have these light clients, there is a nice concept that follows it. Literally, we have a Near node operational inside of Ethereum, which means that in order to break Near, you need to break that node too, which means that you need to break Ethereum. So Ethereum is, it is just some kind of L2 to Near, right? That's it. That's a description of what L2 is. And also Rainbow Bridge obviously makes the whole Near an L2 to Ethereum to some extent. And that is the reason why I'm saying that Aurora is an L2 to Ethereum, because of the fact that Rainbow Bridge exists. Okay, just raise the hands who follows the logic. Okay, not that bad. Now, the complicated part of the solution is that transactions on Near are super cheap, and we are capable of including in a single transaction the whole verification of the Ethereum block. And the cost of the relaying of the blocks is around $2,000 per month if every Ethereum block is relayed to the Near blockchain. Now, the transactions in the other direction is much more complicated, because the native cryptography in Near protocol is not SEPC, so not SEPC signatures. It is Edwards curve 25519 signature, right? And Ethereum has not included in the list of the precompiles the precompile for checking these signatures, which means in order to check the signature of the validator of the Near blockchain, we need to write a smart contract which is actually checking this stuff. This smart contract is extremely complicated, because that's this kind of complicated setup. It has 1,600 lines of code that were even not generated by human. It was generated by a program that was generated by a human on a very, very low level. It is an assembly code, literally. We created a program that has written this to us. That's one of the reasons why this is super complicated thing. So please just reuse all of that stuff. Now, but even with the best optimizations that you can do, you cannot fit the check of multiple signatures in a single Ethereum block. And that's the problem, right? So even without checks of the signatures, all of the other validations from the Near blockchain require around 1.5 million Ethereum gas on the Ethereum chain. And that's the problem. And one single signature check requires additional 1.5 million. Taking into account that Near has 100 validators already, and this amount just grows, like we just cannot fit everything. That's why our approach right now is that for Near to Ethereum kind of transfers, or in general, Near to Ethereum interaction, this interaction is actually optimistic. And by saying optimistic, it means that the logic of how Light Client is working is the following. Somebody submits a new block to the Light Client on the Ethereum side. This Light Client checks everything from this block, whether the structure is correct, whether the validator list is correct according to the current Near epoch and stuff like that. And it assumes that all of the signatures that are provided are correct. They might not be correct, but all of the rest is checked. And then there is a special period, so this block is kept as untrusted. So we are not yet trusting this block. But there are outside services that we call watchdogs that are actually checking whether this block is in a good condition. And in case not, these watchdogs are submitting a challenge. And they're saying, okay, this signature is incorrect. Please check this signature. I'm going to pay for the gas for you checking this signature. In case this signature is in fact incorrect, then this block is discarded. And to be a relayer, to have an ability to send a block to the Light Client, you need to stake 5 Ether. And then in case the watchdog challenges your block, then this amount of money is sent to the watchdog. So that's the economical reasoning to run a watchdog service. So, still following? More or less? Okay. Now that is the design decision that we needed to take because EIP 665 is not yet included in the protocol. And if anyone would like to support any of the EIPs to be added to the protocol, please vote for this. Because this is something that is stopping not only Rainbow Bridge or Near team, this is something that is stopping many different advanced blockchains that are using great cryptography. Edwards curve cryptography at the moment is one of the best existent. So this is something that is stopping good integrations with such blockchains. Yeah, and now what can happen potentially in this setup? Remember, we are permissionless. Anyone can become a watchdog. There is no limitation. If you sorry, not a watchdog. Anyone can become a relayer. Anyone can submit a block. You just need to stake 5 Ether and then you can submit, right? So this opens a vector of attack, which is quite straightforward. You just fabricate the block as if you are removing the liquidity from Near and you're trying to release the liquidity on the Ethereum side. And yeah, potentially somebody can hack it, right? So we've got an attempt. We've got an attempt when it was 1.5 billion worth of liquidity on the Rainbow Bridge. We've got an attempt of such an attack. So on 1st of May, not very far away from now, still market was in much better condition. So that's why it was 1.5 billion of liquidity there. Somebody was trying to do exactly what I just described here. So he just, in a single transaction, he actually applied to be a relayer and submitted also he did 2 actions, one after another. He applied to be relayer, staked 5 ETH, and sent the fabricated block to our RPC. Sorry, not to RPC, to our Near Light Client. And what happened is that watchdogs immediately spotted that something is wrong, submitted the transaction, which is the challenge transaction. And then what happened was something that was not working according to the thing that I was just explaining to you before. the bots that were monitoring the pool of unconfirmed transactions figured out that in case they are going to submit absolutely the same transaction, but from the different address, then something is happening and this address is getting 5 Ether, right? That's kind of a sweet deal. You just send the same transaction, sign it from the different address, pay more gas, get it executed, and yeah, that's kind of great. And that transaction was immediately front run. Immediately. Within seconds, the attack was mitigated automatically. The attack on all of the liquidity that is in the bridge, and potentially not only the tokens, because Rainbow Bridge is a generic bridge. So maybe the person is actually was sending some kind of invalid message, for example. So that is the thing that was happening, and kind of, well, good thing that it happened, that the attack was mitigated, but something is not working right, because watchdogs didn't get anything. So we actually were thinking about this issue, and we were expecting that this is something that is going to happen beforehand, more than half a year before the attack, actually. And we decided to keep the design of this part of the bridge absolutely the same as it was, with one small exception. We decided that it is going to be only a half of the stake that is going to be sent to the person who actually submits a challenge transaction. And obviously we expect this to be an MEV bot, because ordinary people are incapable of competing with these MEV bots, right? Or ordinary scripts that we create. Another part should be manually transferred to the owner, or to the person who actually submitted the transaction that was front run. And we are capable of figuring out who it was, because typically this transaction fails pretty fast, which means that miners are actually including these transactions in the same block, right? There is no point in not doing this, especially because the watchdog script works that it just sends a transaction with a gas price that is twice bigger than the gas price, than the current gas price in the Ethereum blockchain. Kind of cool, right? So in order just to make sure that we are paying something to the MEV bots, we're just sending half of the stake, and another half is going to be manually transferred to the actual watchdog that was submitting this, and the proof of the fact that he submitted this transaction would be just the fact that his transaction is failed. It is the same challenge transaction executed at the same block. Now the question is, why the heck do we need to include here MEV bots? Because the design solution here might be different. For example, watchdogs need to apply to be a watchdog. Then maybe 10 blocks past this moment in time, they would be able to submit challenges. And then MEV is going to be discarded. But we decided intentionally not to do this. And the reason is very, very simple. In case there is an attack on your permissionless and trustless protocol in general, and with optimistic assumptions, the only thing that helps you to mitigate this attack or resist this attack is quick reaction. In our case, quick reaction window is 4 hours, right? It's just because we want it to be on the safe side, make sure that the systems can work. But still, 4 hours, that's kind of a lot from one side. From the other side, it is not enough in case everybody are sleeping, right? Or everybody are on some kind of conference in Paris, right? Or something like that. So it is not that big. So it means that these automatical systems need to figure out the situation. And what is the best system that can submit a transaction to the blockchain? It is MEV bots, surprisingly. So they are not only bad guys, but these people figured out how to super efficiently how to actually submit transactions to the blockchain. And for the optimistic, permissionless protocols, it is insanely important to get transactions executed in order to mitigate these attacks. So, yeah, I literally was covering some portions of the slide. I just wanted to say to everybody that in case you are willing to participate and in case you are using Aurora, in case you are using Rainbow Bridge, you can easily improve the security of the Rainbow Bridge by running a watchdog service. It costs around $5 a month. So for the majority of people who are bridging their funds to Aurora or to Near, this is not a very big cost. This script is not requiring anything like nothing, no complicated things. It just from time to time, once per 10 minutes, actually checking what are the blocks, what is the state of the contract on Near-like client on Ethereum, and checking whether the block is correct or not. Besides the application that I was describing here, with just using the fact that MEV bots are just super proficient in sending and in executing the transactions on the blockchain. Besides that, they are actually doing some additional great things. So, in case somehow the network, and this is kind of more on the Aurora side, right? In case the network can stabilize the MEV activity, and instead of directing the value to the miners of the protocol, direct the value that is extracted from the MEV attacks to the users, then this is going to be super cool. At the current Ethereum landscape, 97% of the value that is extracted from these opportunities is forwarded towards the miners. This is how the Pareto equilibrium is working in Ethereum at the moment. And from some kind of point of view, it is not that good, because this is the value that is extracted from the ecosystem, and maybe just users they were like not thinking that they are going to do kind of bad transaction. And what can be designed is that on the protocol level, on the level of the chain, you can create an ability for these arbitrages and these MEV bots to connect directly to the chain, while given for them also an ability to do the auction, while these profits or this value that they are paying back is actually transferred not to the miners, but rather back to the user who is sending the transaction. So this is kind of advanced thing. Yeah, so I'm just saying to everybody that there are many good things in MEV, so just don't hate it, but also kind of find some good things out of it. And let's build secure apps.
Yeah, thank you so much. Great.